Now, when we actually wanted to determine the density of liquid mixtures, there are two methods of it. Of course, out of those three things, okay, for example, where you look for the values, you estimate it or you measure it experimentally. Now, I would like to bring you to about estimating it, okay, the second one. So, in order for us to estimate the density of liquid mixtures, there are actually two ways of doing that. The first one is we assume a volume additivity, okay, in such a way that, all right, if let's say you want to determine the density. Now let's have a look at the method of determining this density for the liquid mixtures. Okay, if you remember that there are actually three ways of trying to estimate, to get the information of certain properties. For example, like look at the information. Second one is estimating it, and the third one is measuring it experimentally. I'm going to bring you to the second one, where actually we're going to determine the method. There are two methods of determining density of a liquid mixture. So if let's say you have two mixture, okay, you have for example two mixture. You have an A and then you have 3 ml of B. Where you exactly get 5 ml, okay? So somehow we need to know the density. In order for us to determine the density of that, we need to know, for example, like this 2 ml, okay? We need to know what will be the molar fraction of this, okay? And then with this A, and then the B itself, we need to know what will be the molar fraction of this. So if let's say, for example, like we got this as X2. So in order for us to determine the density, the mixture density for this two component, which is A and B, is just simply that you have X1 divided by P1, which is the density for component 1, and then add with X2 divided by rho 2. Okay? And then this one, when you add together, you sum it of it, then it will be equivalent to 1 over a mixture of P. So what you do is actually you invert this, okay, 1 divided by this, and only then you'll be able to get your density. Okay, that is one method that you can do in order for you to estimate the density. The second method that we can use in order for us to estimate the density. So just now, when we have the component of A and B with X1 and X2, okay, what we can do is actually we just determine by X1 multiply with rho 1 plus with X2 multiply with rho 2. And then this will give you the average density, okay, of the mixture. So this is the second method of how you can determine the liquid mixtures densities. Okay, so let's have a look at the example of liquid mixtures. So in order for us to really determine the solution density, okay, determine the density, here is your given problem of sulfuric acid at 20 degrees Celsius, okay, and then you will ask to use a method where either you look up at the values, or you use methods 1 and 2 of estimating it. So if let's say you are looking at it, all right, so you can look at the Paris handbook. Okay, this is where actually you can get from the library, or it is available online. And then from this value, you can see that at 20 degrees Celsius, 50% of sulfuric acid will give you 1.3951 gram per centimeter cube. But if let's say you want to estimate it, okay, because if let's say this value you didn't obtain, you cannot obtain this value, but you were given the information about the, what do you call that? If let's say you were given information about the density of water at 20 degree, this is the value. You were given the density of sulfuric acid at 18 degree, this is the value. So the first method is just simply 0.5, which is the X1, okay, and then this is X2 divided by rho 1, and then this one is divided by rho 2. So you'll be able to get this value. Okay, and then when you invert that, you invert the density, you'll be able to get this particular amount, which is not that far compared to the first value that you have tabulated at. Okay. The second method is also easy, where actually you just need to have the X1 here, okay, multiply with rho 1, plus x2 multiplied with rho 2, then you will get about 1.42. Again, the value is almost similar. So this is, again, you just need to remember that it is an estimation. Okay, it is an estimation. So in order for you to really know what will be the composition, what will be the mixture densities value, is actually to determine it experimentally, as long as you do it right. Okay, so we have looked at liquid and solid mixtures, but what happened to the gas mixtures? Okay, what happened to the gas mixtures, in such a way that I would like you to think about, what if the pressure of a gas in a container increases? What if the volume of a gas in a container reduces? What if heating temperature for a sealed container containing gas increases? What if there are greater number of moles of gas in the container? Okay, so I would like to give you some reflection time so that you can actually try to think about what will happen if, let's say, to the pressure of the gas, okay, in a container, what will happen to a volume itself. And I would like to bring you to a video where actually you can watch on your own, okay. And this video is something that I really like, so that it can entertain you, to make sure that you understand about the gas mixtures itself. Okay, so I'm going to explain you the answer afterwards in the next video.